Hi everyone, myself Satya, Department of Mathematics, SNS College of Technology, Coimbatore. So in today's class also we are going to have the same topic, random process. In last class we just recalled the basic definitions and classifications. Okay, in today's class we are going to start the problems. Okay, the first problem is, see, the process x of t whose probability under certain conditions is given by p of x of t equal to n, that should be equal to at the whole power n minus 1 by 1 plus at the whole power n minus 1, n equal to 1, 2, etc. And the second thing is at by 1 plus at, n equal to 0. This is the function which is given in the problem. Now the question is what? Show that it is not stationary. So we need to verify whether the process is stationary or not. Okay, not stationary means we have to prove it is evolutionary. Okay, so the probability distributions of x of t is, just replace the values for n and take the probabilities. Okay, the first thing is n 0 and n equal to 0, they are given separately, which is at by 1 plus at. N equal to 1, just replace n as 1, so 1 minus 1 is 0, anything per 0, 1, and in the denominator 1 minus 1, again it is actually it should be n plus 1, okay, not n minus 1, there is some mistake here. Okay, and the next thing is 1 by 1 plus at the whole square, and replace n as 2 in the numerator, which is 2 minus 1. In the division actually it is n plus 1, so 2 plus 1 is 3. In the numerator 2 minus 1 is 1. Okay, and see the third case. So n equal to 3, 3 means 3 minus 1 is 2 and 3 plus 1 is 4. Okay, next thing is we are going to find mean, that is e of x of t equal to n equal to summation n into p of n. So just multiply n value and its probability. Okay, the first thing is 0 into at by 1 plus at. The second thing is 1 into 1 by 1 plus at the whole square. Third one is 2 into at by 1 plus at the whole cube plus etc. Okay, now just leave the first term, which is 0, and the remaining terms which is common, yes, 1 by 1 plus at the whole square is common, take outside, and the remaining thing is 1 plus 2 into at by 1 plus at, and the next thing is 3 into at by 1 plus at the whole square plus etc. Okay, and you can check it here, 1 plus 2 at by 1 plus at, that is we are taking that term as alpha. So 1 plus 2 alpha plus 3 alpha square plus etc. So we can write this thing as that is actually a binomial expansion. Okay, so which is 1 minus alpha the whole power minus 2, and just replace alpha value, which is at by 1 plus at, and take LCM as 1 plus at, and find the numerator as 1 plus at minus at the whole power minus 2, and in numerator at minus at will be cancelled. In the remaining one is 1 by 1 plus at the whole power minus 2, just make the negative power as positive, that means we can write it, its reciprocal, so which is 1 plus at the whole square. So 1 plus at the whole square, 1 plus at the whole square, which will be cancelled. Finally we are getting the answer as 1. Okay, and the next thing is just mean is over. So mean is a constant, and the next thing is we need to find the variance. For that we have to find e of x square of t, right, which is equal to n square, because x of t is n here, right, and the formula is what? Summation n square into p of n, and write this n square as, don't replace in this step, just have one more step, after that you can have to follow the same thing. Okay, we can write n square as n into n plus 1 minus n into n plus 1 minus n, and you can separate the terms. Okay, and we get like this, and the first case you just replace n as 0, 0 into anything is 0, and the second thing is replace n as 1, so get the second term, and n as 2 you get the third term, n as 3 you get the third term. Okay, till third you can write the terms, then after that you are having summation n p of n, that is we already done, which is mean value, so that should be equal to 1. And the next thing, just take the common terms in the first bracket, so which is 2 by 1 plus at the whole square, the remaining is 1 plus 3 at by 1 plus at, and 6 into at square by 1 plus at the whole square, then minus 1, and you can take the substitution alpha as at by 1 plus at, so we get 1 plus 3 alpha plus 6 alpha square plus etc, then minus 1. So we can write the first thing as 1 minus alpha the whole power minus 1 and just replace alpha value here, and you get take LCM. After that you can cancel 80 minus 80. Finally we get 2 by 1 plus 80 the whole square into 1 plus 80 the whole cube minus 1. Don't forget this minus 1. Okay. Finally we get 2 into 1 plus 80 minus 1. So 2 plus 280 minus 1, which is 1 plus 280. Finally find variance, so which is e of x square minus e of x the whole square. Just replace the value, so 1 plus 280 minus 1. So the answer is 280, but it is not a constant. So from this we can say this function is not a stationary process. Okay, thank you.